Hello everyone, welcome to another video. We're going to talk about compare branch 0 and unconditional branching in assembly language. So this is an interesting concept because it lets you implement different counters which are useful for a number of applications, but here is one way to do it. Let's dive right into the code. What I'm doing in line 6 is I'm simply moving 3 into register R3. I've got the breakpoints set up. I'm in debug mode already, so I can step 1 instruction and I can see I have this executed now. We have moved 3 in register R3. Now what this is really doing, and you'll see in the rest of the code as we go along, is I've set up how many times do I need something to be executed, a set of instructions to be executed. So this R3 serves as my counter. So I want something to be executed 3 times. This is one way we can do it. So what I can do is define a set of instructions, set 1, and this is where we are. We are going to be, this is hierarchical in nature, so we're going to be looking into the instructions under set 1 now. We've done move R3 in line 6, so the next instruction is the compare branch 0, the CBZ instruction. That's where we are, line 8. So what is CBZ? This is compare branch 0 instruction. It is a conditional branching instruction, which is essentially comparing the value of this register, which is R3 in our case, to 0. You're comparing this value to 0. And if it's true, then we head over to set 2 instructions. So essentially we skip these instructions if this comparison is true. If it's not true, then we go ahead and perform these 2 instructions. So then let's have a look whether or not we have this comparison as true in line 8. Do we really have 0 stored in register 3? No, we just moved 3 into R3, so there's no, we don't have 0 stored there, which means this comparison does not hold. So compare the value of R3 to 0 and it's not true. So we don't go to set 2. What we do is we go to the next line. That is something that we will see. That's the reason why we have these checkpoints set up here. We're going to execute CBZ, and what we should be seeing is that the next instruction would be a subtraction rather than moving the value of 6 in R6, right? So because this is not true, so let's go ahead and see, and that's where we are. We're expecting the next instruction to be a sub instruction, a subtraction, because R3 did not have 0. This was not true. We do not get to go to set 2. We have to go through these instructions. So what is happening in this instruction then in line number 9? We are subtracting 1 from R3 and storing the result onto R3. That's another way of subtracting as compared to what we did in the previous video. So we're subtracting 1 from R3 and overwriting the result. And what does that do? That reduces the value of R3 from 3 to 2. Okay, and that is something that we should see once we execute this. And that is something we do see. The value of R3 is now 2 because we've subtracted 1. Well, after this, what's the next instruction? That's line number 10. We are branching to set 1. Now this is unconditional branching. There's no condition attached to it. There's no comparison attached to it. We branch right away to set 1. That is where we are right now. We execute this and we should, come back to set 1 and repeat this all over again. Remember, the reason why we're doing this is we're trying to implement a counter, and as you can see, we are almost counting now, because from 3 to 1, from 3 we move to 2, and we expect to move to 1 now because R3 is still not 0. So essentially this serves as our counter, because unless this is 0, we come back to this loop again and again and again, right? So R3 is still not 0. You can make that comparison in this line 8, and then you will subtract 1 again, and then branch to this again, then make the comparison and subtract 1 and then branch back. So we'll be doing this again and again. So let's do this again until we arrive at a point where R3 does in fact become 0, and then we get free from this loop and go to set 2, right? So let's step over these. Notice I'm looking into these um, commands. It helps me see that I'm going to compare branch 0, subtraction, and then unconditional branching, right? So that's where my pointer is at. Subtract, branch, still 1, should again compare, subtract, branch again. But now when you've branched and you've come back here into set 1, what you should be seeing is that R3 is in fact 0. So you should go right away to set 2. I should not be seeing a subtraction now. So after this, yes, we compare, but I should not be seeing subtraction. My pointer should be at move because R3 really is 0. So this is true now. Let's see, yes. And you notice the pointer skipped these instructions and moved to the move instruction, right? So you should now, once you execute this, see 6 being stored in R6. So that kind of wraps it up and um, lets us implement a counter, a reverse counter, if you will, where we can count down the number of times we go over a certain counter, a certain register. And of course, this is just an example. We could have multiple instructions or multiple operations, being done between line 9 and line 10, where we could obtain or do certain calculations that we might want to do iteratively, because now we know we come and visit this loop at least 3 times because we moved 3 in R3. If you wanted to visit some instructions after line 9 and between line 9 and 10, you could put in some instructions there, and you would be visiting them as many times as the value that you store in R3, right? Because remember, the comparison is with R3 going to 0. As soon as it goes to 0, we break the loop and head over to set 2. And set 2 could be anything. Here I've just shown that I'm moving 6 in register 6, just to visualize that we've broken out of set 1 and we are into set 2. I hope branching and conditional branching, compare branch 0, made sense. For any questions, feel free to write down in the comments. Thank you so much.